15D, normal random variables, example 11, which continues on from example 10 using the same scenario about women's height, which have a mean of 160 and a standard deviation of 8. First question's pretty standard, just want to know a woman chosen at random has a height greater than 180. So the probability of X greater than, 168. I apologise, I was going too tall, wasn't I? So greater than a height of 168. Now we're going to do this on our calculator. So we go in our stats mode, we go distribution, normal, NCD, variable, 168. Now imagine this, if we look at it from a normal graph, here's our 160 in the middle, here's our 168. We want the probability that they're taller than 168, so in that area. So my lower is 168. My higher is, I just put a lot of 9s in, big number, going for infinity. My standard deviation is 8. My mean is 160. I do that and it tells me that the probability of that happening is 0.15866. I'll round off to 5 decimal places. So about 15, nearly 16% chance that they're taller than 168. Part B says a sample of 4 women is chosen at random. So now what's that going to change? My mean is still going to be 160, but my standard deviation for the sample is going to be 8 divided by the square root of 4. So it's going to be 4. So again, we're still looking at probability of X bigger than 168. So we're still, if we think about graph with 160 here, 168 here, we're still looking for that tail that way. So I'll just go back, remember distribution, normal, NCD, 168 is our lower limit, put in a huge number for our upper limit. The standard deviation is changing to 4. Mean is 160, and now our probability is 0.02275. So a little over 2% chance. And that is example 11.